Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good morning, grade 8 learners. Welcome to our today's natural science lesson, proudly brought to you by the Gauteng Department of Education. My name is Milton Gomo. Let's get ready, put all our activity books in place. Now, let us look at the structure of our lesson today. The knowledge area of our lesson is planet Earth and beyond. The topic of our lesson is beyond the solar system, and the subtopic of our lesson is light years, light hours, and light minutes. Let us go through the objectives of the day as we kickstart our lesson. By the end of the lesson, you are supposed to be able to write the large numbers associated with space distances, and also you're supposed to be able to explain the concepts light year, light hour, and light minute. You're also supposed to be able to measure the distances between stars and other objects beyond the solar system. And finally, you're supposed to be able to explain the concepts of distance and time that has to do with the universe. The source of our lesson is Cape's document, page 54, sorry. Now, let us look at the pre-knowledge that are supposed to recall and recap as we go through our today's lesson. We are supposed to recall the topics that we covered in grade 6, and these include the solar system, systems to explore into space, and systems to explore the moon and the Mars. These are the topics you're supposed to recall. And also, you have to recall one of the recent topics that we covered in grade 8. This one is the objects around the sun. As you can see through the image there, we have got that image which makes us be able to recall this topic that we just talked about recently, objects around the sun. Those objects that you can see there, those are planets, and the big star that you see there is our sun. So you need to recall those topics. With this pre-knowledge, you can as well be able to answer the baseline activity so that as you move on, you are able to understand much better after the recap. Now, number one, we're supposed to write the following in figures. It says from A to F, 1,000, write that one in figures, then 160,000, 1 million, then 799,000, then 1 trillion, and final 2 billion. Right, let us quickly do that activity. I'm going to assign 5 minutes for that activity. Then we do that activity. Then from there, we do corrections. Let's get busy. Right, welcome back. Let us go through our baseline activity and check how much did you manage to recap. Okay, and also remember to send your responses through our WhatsApp number 079-578-2908. Okay, let us go through the baseline activity. You are supposed to write those numbers in figures. The first one is 1000. There is a 1000 in figures is having those three zeros. Then let's go to 160,000. There is 160,000. That's how you write it in figures. Then let's check out 1 million. How do we write 1 million in figures? There is 1 million in figures with six zeros. Okay, let's move on as we go through the next one. 799,000. Let us check this one out. There it is, 799,000. Then if go for the bigger numbers now, that's 1 trillion. There is a 1 trillion with all those 12 zeros. That's a trillion. Then finally we look at 2 billion. There is 2 billion with those 9 zeros. Remember that a billion has got 9 zeros, a trillion has got 12 zeros, then a million has got 6 zeros. Don't forget that. Right, let us write down the corrections quickly. And for those who managed to get all those correct, keep it up. Let us move on to the detail of our lesson. As we look at the terminology, those are the ways that are supposed to master, be able to use with understanding, and also know the clarity of them. Light years, the first one. Let us find out what we're supposed to know about light years. Units of length used to measure distance between light objects. We can just define a light year as the distance that light travels in a vacuum in 1 year. That's a light year. The distance that light travels in a vacuum in 1 year. Right. A galaxy, how do you define a galaxy? A galaxy is simply defined as a collection of billions of stars, space dust, and gas. And all these are held together by gravity. So that's what we mean by galaxy. Let's define an astronomer. An astronomer is a scientist who studies stars, planets, and other objects which are found in space. Right. Our first astronomer, or the one who invented the telescope, his name is Galileo. Right. Recall that. And remember that an astronomer, as we said, is a scientist who studies stars, planets, and other objects in space. If you take a look there in the image shown, we're having an astronomer. There she is, and she's carrying that instrument that you see there. That's the one which is called the telescope. That's an instrument we use to view objects in space. And then we can see the beautiful night sky there with those beautiful stars that are showing off there. And then through the telescope, the astronomer is able to view all the patterns of all those stars. Let us define a star. This one is defined as a massive ball of burning gas. Then the universe is defined as the entire body of all matter and energy that exists in space. As we look at the last part of our terminology, we define a constellation. How do we define a constellation? A constellation is defined as a group of stars that, when viewed from the Earth, they form a pattern in the sky. Right. As you can take a look at that image, we're having patterns formed by those beautiful shining stars that you can see in the night sky that's shown there. Right, if you take a look at there, those stars, they are making various patterns. They are making various patterns. And each pattern of those stars is the one which is called a constellation. Okay, so a constellation is a group of stars that form a pattern, right? You can easily view this while we are here on Earth, right? We've got those famous constellations that include Orion, we've got Ursa Minor, Ursa Major, Taurus, and Gemini, right? Those are the most common constellations. Right, let's move on to Alpha Centauri. How to define this one? This is the name of the closest easily visible star after the sun. Remember that. The star which is closest to us is the sun. Then after the sun, you've got another closest star that you can also easily view it from space. Right, this one is called Alpha Centauri. Okay, that's our terminology. Now let us look at the detail of our lesson. Right, our topic, remember that we said the subtopic of our lesson is light years, light hours, and light minutes. Right, light years. What do we mean by light years? What is a light year? A light year is a unit of length, not time. Okay, a light year is a unit of length. So under this topic, whenever we talk about light years, whenever we talk about light hours or light minutes, know that we're talking about the distance, right, between the stars and planets and other objects in space, not about time. Okay, so a light year is a unit of length, not of time. Right, let's move on. When measuring these vast distances, astronomers use light years, they use light hours, and they use light minutes. Recall the astronomers, these are those scientists that we talked about, the ones that are able to view the what into space. They study stars, they study planets, right? So those are called astronomers. So they use those machines called telescope to be able to measure various distances between all the objects that are found in space, right? And once they take those measurements, they measure into what are called light years. It can be light hours and it can be what? Light minutes. Remember, we just said these are units of length, not of time. Right, even though a light seems like a unit used for measuring time, a light year measures distance. Always recall this, that in as much as the light might appear to be a unit of measuring time, it is not, okay? A light year measures distance. Now let us look at some few distances that are shown there, right, in light years, okay? We are going to take our Earth as a reference point, right? It says how many light years away is the Earth, okay, from those given stars and other objects in space, right? Earth is approximately 8.3 light minutes from the sun. There is the sun shown, okay? So between the Earth and the sun, we're talking about a distance of about 8.3 light minutes, okay? Then the Earth is also approximately 4.3 light years away from Proxima Centauri, and remember that this one is our second closest neighboring star after the sun, right? The closest star to us is the sun, recall that. Then the second closest star to us is Proxima Centauri, right? So now it takes approximately 4.3 light years to move from Proxima Centauri to the sun, okay? Right, to the Earth, okay? There we are. The Earth is approximately 320 light years from the North Star, which is called Polaris, okay? Then the Earth is approximately 26 light years away from the center of our galaxy. Recall our galaxy, our very own galaxy is the Milky Way galaxy, right? We spoke about that one in the recent lesson. So between the Earth In the center of Milky Way galaxy, we're talking about a distance of approximately 26,000 light years. So a light year is a unit of length, right? Not of time. So recall that. Let's move on. I want to find out in detail what we need to know about the light years, light hours, and light minutes. Light is the fastest speed we know and can travel about 7 times around our planet Earth in 1 second, right? That's how fast light moves. It's so fast, right? There's no speed other than speed of light. It is the fastest so far. Okay? So now it takes about 1 light year. When we talk about 1 light year, we're talking about a distance of about approximately 5.880 trillion miles or 9.5 trillion kilometers. 1 light year is approximately equivalent to a distance of 9.5 trillion kilometers. So each time we talk about 1 light year, know that we're talking about an approximate distance of 9.5 trillion kilometers. That's 1 light year. Then we talk about the Milky Way, our very own galaxy. We also have to know a lot about our own galaxy, right? The Milky Way is about 100,000 light years across. Right, if you can check the image of the Milky Way galaxy there, you can realize that if you were to recall our Milky Way galaxy from this end to the other end, we're talking about a distance of about 100,000 light years, which means if you were to try to cross through the Milky Way galaxy, you would take that 100,000 light years. That's the distance which separates the two ends of the Milky Way galaxy, which is our very own galaxy. Light years, as we continue, let's find out how we can be able to understand this concept of light years and what exactly do the astronomers use as they gather information about the distances between stars, between planets, or all the other objects in space. How do they manage to come up with these measurements? Right. Note that a light year is not a measure of time, but it is a unit of distance. Right. Let's look at the diagram given there and then find out what exactly do the astronomers use and how are they able to come up with the measurements between these stars in light years, in light hours, and in light minutes. Right. There is our sun, as you can see. That's our sun, which is found in the Oort cloud there. Right. If I choose now just to pick out an object that is found within space and also closer to the sun, let's just pick out one of those stars that are shown there. This is Alpha Centauri, right? There it is. Then next to Alpha Centauri, we've got that smaller star, which is Proxima Centauri. Remember that Alpha Centauri and Proxima Centauri, they form that triple star system. Triple star system. Okay, we're talking about the Alpha Centauri and Proxima Centauri. Right? Why is it called the triple star system? If you are to recall there, we've got Alpha Centauri, Centauri what? A, and Alpha Centauri B. Right? So right now we've got how many stars? We've got 2 stars. Then we've got Proxima Centauri. Okay? Proxima Centauri. Now we can label that one as C. How many stars do we have now? We've got 1, 2, 3. And those stars, they form the triple star system. Right. If we were to just pick one of those ones, which is in this case, we can choose to pick Proxima Centauri. Now, we want to find out how many light years separate Proxima Centauri from the Sun. What we do, we check the location of the Proxima Centauri, which is that one, right? Then we check the orbital levels, which show the number of light years in each of them, and then check where exactly is the object we're dealing with, right? There it is, Proxima Centauri, right? Where is it located? We check here. The first orbit there is in the what? Level of 2 light years. Then second one is in the level of 4 light years. And that's exactly where our Proxima Centauri is located. So we can now say that Proxima Centauri is about 4 light years away from the Sun. Okay? Then if you were to pick out that other one, which is over there, the Y's. Look at that Y's, right? How many light years separate Y's from the Sun? We're talking about 6 light years, because that's where it is located, in the orbital level of 6 light years. So just look at the location of the object in space and then check the number of light years given there. Then are able to read the information. Then now you'll be having a clear measurement of light years between the two stars or planets or those objects. Right, that's how you are able to read the measurements between stars in light years, maybe light hours, air, light minutes. Right, with that being said, we can now safely be able to answer our first activity, which is activity number 1. Right, in this case, we're supposed to define a light year and also state about how many light years away is the Earth from the Sun. Number 3, the Earth is about 26,000 light years from the center of our galaxy. What do we need to do? We need to name our galaxy, right? Then number 4, the Milky Way galaxy is about how many light years across? Then final number 5, right? 1 light year is approximately how many kilometers? Let us quickly do that activity. I'm going to assign to you 4 minutes for that. Then quickly look at the corrections once you are done. Right. Welcome back. Let us look at the activity that we just did and then check out the possible answers to it. The first one is supposed to define a light year. We're supposed to define a light year. How do you define a light year? A light year is defined as the distance that light travels in a vacuum in 1 year. Number two, about how many light years away is the Earth from the Sun? We're talking about a distance of 8.3 light minutes. Okay, so the distance between the Earth and the Sun is approximately 8.3 light minutes. The Earth is about 26,000 light years from the center of our galaxy. Which galaxy are we talking about here? We're talking about our very own Milky Way galaxy. That's our galaxy. Remember that we've got millions of galaxies in the universe, but our own galaxy is called the Milky Way galaxy. We call that. The Milky Way galaxy is about how many light years across? It is about 100,000 light years across. That's the Milky Way galaxy. The last one light year is approximately how many kilometers? We're talking about 9.5 trillion kilometers. So that's the solution to that question and the responses to all of those questions. Remember to send your responses through our WhatsApp number. Okay, let us write the corrections, and for those who managed to do well, keep it up. Let us proceed and look at the next part of the lesson as we continue with light years, light hours, and light minutes. Right, remember that we just say that a light year, we're talking about a distance that the light travels in a vacuum in 1 year. That's a light year. The distance that light travels in a vacuum in 1 year. Which means if I talk about the light hour, we talk about the distance that light travels in a vacuum in 1 hour. And also the same about light minutes. Okay, we'll talk about the distance that light travels in a vacuum in 1 minute. Okay, so those are the description of those distances. 1 light year is the distance that light travels in a vacuum in 1 year. 1 light hour is the distance that light travels in a vacuum in 1 hour. A light minute, the distance that light travels in a vacuum in 1 minute. Okay, now let us look at those triple star systems that we're talking about. Alpha Centauri A and Alpha Centauri B are 42 trillion kilometers away from us. And if you can take a look, these numbers are astronomically large. They are very big, these numbers. Okay, so it's very difficult to work with such large numbers. We're talking about 42 trillion kilometers. That's a very huge number. So what do the astronomers do? As the numbers are so large, astronomers do not use kilometers to measure the distances to stars. But what do they use? They use larger units based on the speed of light, which is called the light year. This is the fastest speed. There is no any other speed faster than the speed of light. So astronomers devised a very good way of writing these large numbers of distances of space objects, and then they use a more improvised way, which is light years, light hours, or light minutes. So it made it so easier to understand the concept of our science. Right. Back then, if we had to check again, we once discussed that diagram. Okay, when I was explaining about location of those objects in space and also being able to identify or being able to find the measurements that separate the two stars or planets from each other, given the diagram like this one. Okay, remember when we were to speak about the location of Proxima Centauri and Alpha Centauri, and these are located approximately 4 light years away from the sun. We're talking about a distance of about 4 light years. So that's how we're able to take those measurements or read those measurements which separate any two objects which are found in space or more than. Okay, light years, light hours, and light minutes. As we continue there, what you need to know, the distance which separates the Earth to the moon, we're talking about 1.29 light seconds, which means to travel from the Earth to the moon using the measurements of light years, we can only take 1.29 light seconds, which can be rounded off as 1.3 light seconds. And then from the Earth to the sun, we talk of about a distance of 8 light minutes. So to move from the Earth to the sun using the measurements of light years, you can only take 8 light minutes. Remember to always include that light in your measurements so that we're able to separate the measurement from the common measurements. It's not 8 minutes, but it's 8 light minutes. Okay, it's not 1.29 seconds, but it's 1.29 light seconds, because this measurement is based on the measurement of space distance, which is done in light years or light hours or light minutes and light seconds. Right, from the Earth to planet Mars, we talk of a distance of about 12.7 light minutes. Okay, then from the Earth to Proxima Centauri, which is the nearest star closest to the sun, we talk about 4.3 light years. Okay, and then from the Earth to the other side of our Milky Way galaxy, we're talking about a distance of about 52,000 light years. So those are just a few selected distances that you are supposed to always recall and know as we proceed with the lesson. Now, a light year is the distance that light travels in 1 year. That's a light year. If we talk about light year, we're just talking about the distance that light travels, okay, in 1 year. It's called a light year. 1 light year is about 10 trillion kilometers. That's 1 light year. A light hour is the distance that light travels in 1 hour. Okay, now it's making a lot of sense as we talk more and more about it, so that you're able to understand exactly what you mean by light years, light hours, light minutes, and light seconds. Our solar system has a diameter of about 13 light hours. A light minute, it is the distance that light travels in 1 minute. That's a light minute. That's the distance that light travels in 1 minute. The Earth is about 8 light minutes away from the sun. So those are the measurements we're supposed to always note and master and use. So with that, we come to activity number 2. Right, look at those questions 1 to 3. Which planet orbits around the sun the fastest? Then from there, you explain your answer. Okay. Number 2, which planet's year is shorter than its day? Which planet is got its year shorter than its day? Which is really sounding strange, you know? Then we are able to explain that using the detailed energy. Number 3, plot a bar graph to show the distance each planet is from the sun. So in number 3, we are plotting, in this case, don't plot any type of graph, but plot a bar graph so that you're able to show, right, the distances, right, that separate each planet from the sun. That's 4 minutes for this activity. Then quickly look at the corrections. Right, welcome back. Let us look at the activity and go through the solutions. Right, number 1, it says which planet orbits around the sun the fastest. Then from there, you to explain your answer. Right, we're talking about planet Mercury. This is the planet which orbits around the sun the fastest. Right? Why? It's because it is the closest planet to the sun. Remember that from those 8 planets, the closest one to the sun is Mercury, right? Just because it's closer to the sun, Mercury is able to orbit around the sun faster than any other planet, right? And besides that, it has got a least distance to cover, right? It's closer to the sun and only covers a distance as it orbits around the sun. Therefore, the speed of this planet is faster than another planet. Number 2, which planet here is shorter than its day? Which planet has got its year shorter than its day? And this planet we're talking about is none other than planet Mercury. Once again, right? Number 3, I'm supposed to plot a bar graph showing the distance each planet is from the sun. Right, there it is. There is our bar graph. Remember that the one closest to the sun, we're talking about Mercury, right? Okay, then our distance there from the sun, and this is in million kilometers, right? So we'll talk about millions of kilometers separating each planet from the sun. If I were to pick planet Mercury, it is less than a million, almost 0 millions away from the sun. Then the second one is Venus, right? There it is. Okay. Then there is planet Earth. Okay, it's planet Earth, right? Remember that planet Earth is separated from the sun. If I were to try to take a look there, this is 0, then up to 500 what? Million kilometers. So the distance from the Earth to the sun, remember, it is 150 million kilometers, right? Which is between that 0 mark and 500 million kilometers. So all those first 4 planets, which include Mercury, Venus, Earth, and Mars, they are all less than 500 million kilometers away from the sun. Okay, then now we've got planet Jupiter, which is around 1.5, we'll talk about 1.5, 1,500 million kilometers away from the sun. Okay, that's planet Jupiter, right? Then we've got Saturn, which is almost 1.8 million kilometers away from the sun. We'll talk about 1,800 million kilometers away from the sun. Then the one which is furthest away from the sun, that's Neptune. This one is the furthest planet away from the sun. Remember that this is measured in million kilometers. Therefore, if we were to pick out Neptune, it goes up to 4,500 million kilometers away from the sun. So it is furthest away from the sun. So that is a simple bar graph you're supposed to note. Let us quickly copy that bar graph as our correction so that we are able to understand as we proceed with our lesson. Right. Now, let us look at this detailed table which clarifies how fast is the speed of light we're talking about. Remember that we just said the speed of light is the fastest speed on Earth, okay? There is no any other speed quicker than this, right? Distance traveled by light. Distance traveled by light in just 1 second, okay? In 1 second, light can travel between Cape Town and Johannesburg 214 times. That's a very, very fast speed. You can see how fast light travels, right? Can travel between Cape Town and London, which is in England, 31 times. That's how fast light is. Remember that from here to London, from Cape Town to London, we just have to use aeroplanes, okay? Because that's a very massive distance we're talking about to separate the 2 places, okay? The 2 cities, of course, right? If you were to use a car or public transport, road transport, it would take months and months and months. But now for the light, it only takes about a second to travel from Cape Town and to England. And this can be done 31 times in just 1 second. So the speed of light is very, very fast. Okay? And in 1 second, light can travel around the Earth about 7.5 times. Imagine the light. Okay? Which means it can travel all the way from its source, which is the sun, to the Earth about 7.5 times in just 1 second. That's a very fast speed we're talking about here. Light takes 0.000003 seconds to travel 100 meters. It is very fast. Light takes 1.3 seconds to travel from the Earth to the moon. Then also need to know that light takes only 8 minutes to travel from the sun to the Earth. Only 8 minutes. That's a very fast speed to talk about here. Always recall that. Right. As we continue with the light years and also making a quick recap on some of the stars that we need to always get reminded of, and also the planets as well. Right. The first one there, we're having the moon, right? Between the moon and the Earth, light can travel about 1.3 light seconds. That's so fast. That's how fast is the speed of light. Light, once again, can only take about 8.3 light minutes to travel from the Earth to the sun. Okay? Right. So I'll talk about a very fast speed here. Then also we have to remember the triple star system, and one of them is the star called Proxima Centauri. Okay? Remember that in the triple star system, we've got Proxima Centauri, then we've got Alpha Centauri A and Alpha Centauri B. Those 3 stars combine to make the triple star system, which is always referred to as the Alpha Centauri, which is the second star closest to us other than the sun. Now, between Proxima Centauri and the Earth, light can only take about 4.2 light years. Okay? Now, Alpha Centauri and Proxima Centauri are about 4 light years away from the sun. Okay? If you had to remember the diagram that we talked about, where you just look at the location of your star. Okay? In that case, we had our sun there. Okay? Then this was 4 light years. And then just next to that orbital level, we had our Proxima Centauri. There it is, Proxima Centauri. So now, if we were to take the measurement there, we just say our Proxima Centauri, our star, is located in the orbital level of 4 light years. Hence, the distance between Proxima Centauri and the sun is approximately 4 light years. Okay, right, let's move on. Let's look at the next activity, which is activity number 3. In this case, we are supposed, number 1, to give the name of the galaxy in which our solar system is found. Number 2, what does the Milky Way galaxy consist largely of? Number 3, how many light years is it across the Milky Way galaxy? Then finally, what is an astronomer? Let's go again for another 4 minutes. Right, welcome back. Let us look at the solution to our activity. Right, number one, give the name of the galaxy in which our solar system is found. Our galaxy, remember once again, that's the Milky Way galaxy. Number two, what does the Milky Way galaxy consist largely of? We're talking about the stars, the dust, and gas. Those are the components of our Milky Way galaxy. Then number three, how many light years is it across the Milky Way galaxy? Is about 100,000 light years. What's an astronomer? This one is a scientist who studies stars, planets, and other objects in space. Right, let's quickly write those corrections, and well done for those who did well. Okay, let's move on. And this time around, as we summarize our lesson, we use light years, light hours, and light minutes to measure vast distances, right? One light year is the distance light travels in 1 year. 1 light hour is the distance that light travels in 1 hour. And 1 light minute is the distance that light travels in 1 minute. Okay? It takes about 8 light minutes to travel from the sun to the earth, which means the light only takes about 8 light minutes to travel from the sun to the earth, as shown there in the image. It takes 1.3 light seconds to travel from the earth to the moon. The Milky Way is 100,000 light years across. That's our very own galaxy, the Milky Way galaxy. Alpha Centauri A and Alpha Centauri B are 42 trillion kilometers away from us. One solar system has a diameter of about 13 light years. A light year measures distance, not time. 1 light year is approximately 5.880 trillion miles or 9.5 kilometers. Last part of the summary. An astronomer is a scientist who studies stars, planets, and other objects in space. The distance from the Earth to the other side of our Milky Way galaxy is about 52,000 light years. Then there's our homework. Let us quickly cover those questions 1 to 3. Number 1, how many light years is it from the sun to Proxima Centauri? What's the difference between a light year and a light hour? It takes how many light seconds from the Earth to the moon? Our next lesson will be looking at the topic beyond the Milky Way galaxy. And remember to send your solutions through our WhatsApp number. With that being said, we come to the end of our lesson. Thank you so much. Let's meet next time.